When a celestial body as massive as Jupiter strays from its predicted path, Betelgeuse, one of the brightest stars visible in our night sky, undergoes a puzzling transformation that has astronomers both captivated and excited. Imagine a star so vast that, if positioned at the center of our solar system, it would dwarf the Sun and engulf all planets up to Jupiter. This giant is Betelgeuse, a red supergiant in the Orion constellation, long admired for its deep red hue and immense scale. However, this stellar behemoth is now behaving unpredictably, keeping scientists on edge. In a striking development, Betelgeuse has recently surged in brightness, increasing its luminosity by over 50% and climbing from the 10th to the 7th brightest star in the night sky. This dramatic change has left scientists baffled and eager to unravel the mystery behind Betelgeuse's transformation. What could be causing this remarkable behavior? Is Betelgeuse on the brink of a cataclysmic event? Or is this just a temporary phase in the star's life cycle? To understand the significance of Betelgeuse's strange conduct, we must delve into the factors that contribute to a star's brightness. A star's luminosity is determined by its size, temperature, and distance from Earth. Betelgeuse is a true giant among stars, with a radius more than 700 times that of our Sun. Despite its enormous size, Betelgeuse is relatively cool for a star, with surface temperatures ranging between 3,000 and 3,500 Kelvin, which gives it its distinctive red color. Throughout history, ancient civilizations have been fascinated by Betelgeuse and have woven the star into their mythologies and folklore. The ancient Egyptians connected Betelgeuse with Osiris, the god of the underworld, while the Greeks associated it with the legendary hero Orion. These myths underscore the enduring allure of this extraordinary star. As astronomers investigate Betelgeuse's erratic behavior, they grapple with pressing questions about its future. The stakes are high, and the possible outcome could be truly cosmic. If Betelgeuse is indeed approaching a supernova explosion, it would be a once-in-a-lifetime spectacle, lighting up the night sky like never before. The blast would be so intense that it could even be visible during the day, casting shadows on Earth and offering an unparalleled chance for scientific exploration. But the big question remains, is this the quiet before a cosmic storm, or merely a fleeting anomaly in the life of a stellar giant? To understand this, it's essential to recognize the immense size of the star and its current phase in the stellar life cycle. Betelgeuse is a red supergiant, an aging star approaching the final stage of its existence. Much like living organisms, stars are born, evolve, and eventually perish. They originate in nebulae, vast clouds of gas and dust, where gravity draws material together to form protostars. As these protostars accumulate mass and heat, nuclear fusion ignites in their cores, signaling the birth of a new star. Over millions or even billions of years, stars like Betelgeuse consume their nuclear fuel, first fusing hydrogen into helium, then helium into heavier elements. As they age, their internal processes shift, triggering a series of transformations. When a star with a mass comparable to Betelgeuse depletes its fuel, as a massive star depletes its fuel, it expands dramatically, transforming into a red supergiant. At this stage, its outer layers are loosely bound by gravity, making the star highly unstable. A red supergiant like Betelgeuse will ultimately succumb to its own immense gravity, collapsing and triggering a spectacular explosion known as a supernova. Supernovae rank among the most energetic and brilliant events in the universe, releasing vast amounts of energy in a brief span. Betelgeuse is expected to undergo a Type II supernova, which occurs when a massive star can no longer sustain its own weight after exhausting its nuclear fuel. The core collapses, setting off a powerful shock wave that rips the star apart, propelling its outer layers into space at astonishing speeds. If Betelgeuse were to explode, it would be an unparalleled cosmic spectacle. The first indication of the approaching explosion would be an immense surge of neutrinos, elusive subatomic particles that seldom interact with matter. These neutrinos would escape from the star's core just moments before the shock wave, reaching Earth hours ahead of the supernova's light. Global observatories would play a vital role in detecting this burst, providing astronomers with an early warning of the impending event. As the shock wave erupts from Betelgeuse's surface, the star would explode, unleashing an enormous amount of energy in the form of light, heat, and radiation. The supernova would rapidly brighten, becoming visible to the naked eye even in daylight. At its peak, the explosion could outshine the full moon, casting shadows and illuminating the night for weeks. Astronomers are buzzing with excitement over the possibility of Betelgeuse going supernova. Dr. Emily Thompson from the University of California, Berkeley, describes it as a ticking time bomb, emphasizing the rare opportunity to witness its final stages. A supernova of this scale would be a once-in-a-lifetime spectacle, offering invaluable insights into stellar evolution, nuclear physics, and the universe's chemical enrichment. However, in late 2019, Betelgeuse took an unexpected turn, dimming rather than continuing its anticipated brightening. Betelgeuse's dimming was so pronounced that it could be seen with the naked eye, with the star losing about 60% of its usual brightness. This unexpected change left the astronomical community baffled, prompting scientists to intensify their observations in an effort to uncover the reason behind its fading light. The phenomenon presents an intriguing challenge for astronomers. Could it be a precursor to a supernova? Or is there another explanation for this unusual behavior? As speculation grows, the mystery deepens, and anticipation mounts as we await further observations and data. The story of Betelgeuse is far from over. The fate of this mysterious star holds crucial insights into the nature of the universe and our place within it. Betelgeuse continues to intrigue astronomers as its unpredictable behavior fuels new theories and observations. Defying expectations, the red supergiant keeps scientists racing to solve its mysteries before the cosmic drama reaches its peak. In late 2019, astronomers were stunned when Betelgeuse, one of the brightest stars in the night sky, began to dim without warning. A long-standing celestial landmark, it was now visibly fading. Various theories arose, from dust blocking our view to a significant surface disturbance. Yet the exact cause remained elusive. As the dimming continued, astronomers turned their telescopes toward Betelgeuse, determined to uncover the truth behind this cosmic enigma. The Very Large Telescope VLT, in Chile, one of the most advanced observatories in the world, managed to capture a series of images that would prove crucial in understanding the star's behavior. The VLT images revealed that Betelgeuse's appearance was far from symmetric. The star, which had once appeared as a uniform disk, now had a distinctly lopsided shape. It was as if a cosmic hand had reached out and squashed the star, leaving it misshapen and distorted. But the asymmetry was just the beginning. As astronomers analyzed the data, they discovered the presence of a huge shock in our line of sight. This shock, which was unlike anything they had seen before, seemed to be emanating from the star's surface, suggesting that something truly extraordinary was happening on Betelgeuse. To understand the significance of these discoveries, we must first examine the concept of a photosphere. The photosphere of a star is essentially its visible surface, the layer from which light radiates into space. For a long time, astronomers believed that Betelgeuse's photosphere remained relatively stable, with only slight fluctuations over time. However, images from the VLT revealed a different reality. They showed that Betelgeuse's photosphere was expanding, causing the star to appear larger than ever before. It was as if the star were slowly inflating like a cosmic balloon, propelled by an unknown force. Betelgeuse, a red supergiant, has already exhausted its hydrogen fuel and is now fusing heavier elements in its core. This process is less efficient and causes instability, pushing the star closer to its inevitable explosion. However, even if Betelgeuse were to go supernova today, we wouldn't witness it immediately. Located about 650 light-years from Earth, any light or signal from the explosion would take 650 years to reach us.